So in this one, we're multiplying binomials, so we need to distribute. 1 times 1 is 1. 1 times cotangent is cotangent of x. Negative tangent minus 1, that would be negative tangent of x. And then I have negative tangent times cotangent. That would be negative tangent cotangent. Okay, now tangent times cotangent, we can simplify that. Tangent is the same thing as sine over cosine. And cotangent is the same thing as cosine over sine. So all those will cancel out, and we'll just be left with a 1. So now I have 1 plus cotangent minus tangent minus 1. Well, the 1 minus 1 cancel, and so we're left with cotangent minus tangent. Here it says find the 5 remaining trig functions given that cotangent of alpha is negative 5 over 3. And it also tells me alpha is between negative pi over 2 and 0. All that means is alpha is in the 4th quadrant. So I'm going to draw my triangle in quadrant 4. Here is my reference angle for alpha. And now cotangent is the adjacent over the opposite. So that means my adjacent side would be 5. My opposite side is 3. Now I can find the missing side, which is the hypotenuse, by using the Pythagorean theorem. So I've got 3 squared plus 5 squared is going to equal the hypotenuse squared. So 9 plus 25 equals c squared. So c squared is equal to 34. Take a square root of both sides. That tells me c is equal to radical 34. So my hypotenuse, the missing side here, is radical 34. It looks like when you did it, you treated it as a 3, 4, 5 Pythagorean triple. And that's fine, or that could work only if the 5 was the hypotenuse. But because the 5 here was the other side, that means this can't be 3, 4, 5. Otherwise, you're saying the hypotenuse, which has to be the longest side, is 4, which is shorter than this leg, which is 5. So we know that 3, 4, 5 doesn't work here because it's the hypotenuse, so we have to use the Pythagorean theorem. I'm going to trust you could find all the ratios from there. Looks like you were doing that correctly. Like I said, you just messed up the missing side length. So here we're determining if it's even, odd, or neither. So the way we determine even or odd is we plug in a negative x everywhere we saw an x. So here that was going to give me negative x minus secant of negative x. And now, if after I simplify this, if every sign stays the same, it's even. If every sign is different than the original problem, then it's odd. And if neither one of those things happen, then it's neither. So negative x is going to stay as negative x. Now we have negative secant of negative x. So secant is the reciprocal of cosine. We know cosine of negative x, we just drop the negative. It does not come out front for cosine. So that's the same with secant. So this negative that's inside the argument is just going to get dropped. We don't bring it out front. So I have this negative that was already part of the problem, and then secant of negative x just stays as secant of x. So now this is as simplified as it can get. Now, is this the exact same as the original problem? No, it has a different sign at the beginning. Is every sign different than what we started with? No, this one is still negative. So because neither one of those things happened, the answer here would be neither. So now when I look at this problem, it's sine squared minus 5 sine plus 6. So that looks a lot like a quadratic function that you would have factored in Algebra 1 or Math 112. It's x squared minus 5x plus 6. So So now I'm looking what multiplies to be positive 6, but combined is negative 5. That would be an x minus 3 times x minus 2. I just factor that by sight. I'm not sure how you're used to factoring. Another way some people teach to factor is to do the a times c method. So if that sounds familiar, you would do that here. So this is what it factors to be. But remember, I didn't start with an x. I substituted an x in where I used to see a sign. So if this is x minus 3 times x minus 2, we could write that as sine of alpha minus 3 times sine of alpha minus 2. Listen, what they want us to do is rewrite everything in the numerator in terms of cosine. So I have cosine cubed of alpha, and then plus cosine of alpha, and then I have sine squared. But because I know sine squared plus cosine squared equals 1, I can rewrite that to say sine squared equals 1 minus cosine squared. Sine squared equals 1 minus cosine squared. So here where I used to say sine squared, I can substitute in 1 minus cosine squared of alpha. Okay, so this is the first answer there. From here we need to distribute. So I'm going to be left with cosine cubed of alpha plus cosine of alpha times 1 is cosine of alpha. Cosine times negative cosine squared. So that's a cosine to the first times a cosine to the second. That's going to leave me with a negative cosine to the third. That's your second answer. Now we're combining like terms. So I have a cosine cubed minus a cosine cubed. So those cancel. So that leaves me with cosine of alpha in the numerator. That's the third answer. Over sine of alpha. And then cosine over sine can be rewritten as cotangent. That's the fourth answer. So you get sine of pi over 4 plus pi over 3. So this is the sum of angles formula. So this is like sine of alpha plus beta. We can rewrite it as sine of alpha cosine of beta plus sine of beta cosine of alpha. So for us here, that's going to be sine of pi over 4 times cosine of pi over 3 plus sine of pi over 3 times cosine of pi over 4. Sine of pi over 4 is radical 2 over 2. Cosine of pi over 3, that's a 60-degree angle. Cosine would be the adjacent over the hypotenuse, so that's 1/2. Plus sine of pi over 3, that's going to be radical 3 over 2 times cosine of pi over 4, that's radical 2 over 2. So now we multiply. Radical 2 times 1 is radical 2. 2 times 2 is 4. Plus radical 3 times radical 2 is radical 6. Over 2 times 2 is 4. They have a common denominator, which means we can write this as radical 2 plus radical 6 all over 4. This is really the same thing as the last problem. So 105 degrees, that would be a reference angle of 75. That's not one of my special right triangles that I have memorized. So I want to rewrite this as a sum of two angles. So we can rewrite this as sine of 45 plus 60. So then this is sine of 45 cosine of 60 plus sine of 60 cosine of 45. I mean, this is literally the exact same as the last problem we worked. This is radical 2 over 2 times 1 over 2 plus radical 3 over 2 times radical 2 over 2. I'll stop right there. But like I said, it's a sum of angles again, just like the previous. So this is similar to the last ones, except now then we have to set up our triangles. So it tells me sine of alpha is negative 15 over 17, and alpha is in quadrant 3. So I'm going to draw that. So if this is my reference angle for alpha, sine is the opposite, which is 15 over the hypotenuse, which is 17. So you could find that missing side of the right triangle using the Pythagorean theorem. Or this is a Pythagorean triple. This is an 8, 15, 17 special right triangle. Either way. So there's my triangle for alpha. And now we're going to draw the triangle for beta. So it tells me beta is in quadrant 2. So when I draw that triangle, I'm going to put it in quadrant 2. This is my reference angle for beta. And it tells me beta is the adjacent. We're talking about cosine of beta. Cosine is the adjacent, which is 21, over the hypotenuse, which is 29. So again, you could do the Pythagorean theorem to find the missing side, or this is another Pythagorean triple. This is a 20, 21, 29 Pythagorean triple. And so now I've got both of those triangles set up. And so because I'm finding sine of alpha minus beta, that's a difference of angles. So this is sine of alpha times cosine of beta. This time it's minus sine of beta cosine of alpha. And so here's sine of alpha. Because I'm in the third quadrant, that's going to be negative. Sine is the opposite over the adjacent. Now we're going to find cosine of beta. Because I'm in the second quadrant, cosine is negative. Beta is the adjacent over the hypotenuse. That's a 29 down there. Let me rewrite that. And there's a built-in minus in the formula. And now we need to find sine of beta. So I go to beta. It's in the second quadrant. So sine is positive. Sine is the opposite over the hypotenuse. So that would be 20 over 29. And then cosine of alpha. So here is alpha. It's in the third quadrant. That means it's going to be negative. Cosine is the adjacent over the hypotenuse. So it would be 8 over 17. And then we just multiply this. So you could put it all in your calculator at once. I have to get my calculator to do this. So 15 times 17 is 255. 17 times 29 is 493. And then a negative times a negative, that's going to be another positive. That's going to be 493 on bottom again. And then 20 times 8 is 160. So now 255 plus 160 is 415 over 493. All right, I need to go back in. I need to fix something. Sorry. So 15 times 21 is 315, not 255. Not sure what I put in my calculator. So this should be 315 over 493 plus 160 over 493, which means my correct answer is wrong. I don't know if it'll let me erase it. There it goes. So this is going to be still over 493. 315 plus 160 is 475 over 493.